Okay, this video is just to help remind you of some of the applications that we can do with trig functions. And two of the key words that we need to remember when it comes to trig applications are angle of elevation and angle of depression. Angle of elevation is pretty straightforward. When we think of elevation, we always think of going upwards. So an angle of elevation is just an angle that rises from the horizontal, or if you had a horizontal line drawn here, your angle of elevation is going upwards from there. An angle of depression is a commonly confused one. Oftentimes when people think of angle of depression, it might be a problem where you're standing on a hill looking downwards. And often people try to place their angle underneath where they're looking. But you got to remember that if your line of sight is at horizontal line, your angle of depression is actually dropping downwards from the horizontal. So when it comes to application problems, you might see a problem such as this. An airplane takes off with an angle of elevation 30 degrees and travels 4,500 feet. So what is the altitude of the plane? So the first thing we need to sort of imagine is where that plane is heading. So it's going to kind of take off from where we are here, forming a nice right triangle. So as the plane takes off, it's going to head off this direction. And it's traveling 4,500 feet. Again, that's where the plane travels. So it's going to be our hypotenuse. And with an angle of elevation, so from the red horizontal line, we are rising 30 degrees. And if we're looking for the altitude, remember altitude is just a line directly from the top downwards. So directly from where the plane is headed down. So we're looking for, from the 30, our opposite side. Well, if we're looking for the opposite using the hypotenuse, remember opposite and hypotenuse, when I think SOHCAHTOA, are going to be the SO. So the sine of 30 degrees is equal to x over 4,500. If I multiply that denominator over to the other side, we can solve for x fairly simply. 4,500 times the sine of 30 degrees equals x. And if you remember from our special triangles, 30, 60, 90 triangles, the shortest side is always half the hypotenuse because the sine of 30 is always equal to exactly 1/2. And we can quickly find that 2250 feet, or 2,250 feet, would be the answer to our problem, or the altitude after having traveled 4,500 feet. Again, that's a good angle of elevation problem. And here's an example of an angle of depression problem. Let me expand the screen here for just a second. Okay, there we go. Now we can see the full problem. Again, reading through the problem, we're standing on a sheer cliff, and we see a bison down below us. So that line's going to drop down that way. The angle of depression from us to the bison is 18 degrees. So again, from the horizontal, our angle of depression is 18 degrees right here. Now we can use that in a couple of different ways. This sheer cliff creates a nice right triangle. So we've got our right triangle formed between the bison, between the bison and the cliff. That 18 can help us with another 90-degree angle right here. If this is a horizontal and our horizontal down here, we've got a 90-degree angle. So 90 degrees minus 18 degrees can tell us that the angle inside the triangle is 72 degrees. You could also think back to some geometry. You have a parallel line here and a parallel line at the ground. So alternate interior angles are equal. So if this is 18 degrees here, so will this angle at the bottom be. And again, you can use either one of those two angles. We also know the cliff is 300 feet high, according to the problem. And the first question is asking us, how far are we from the bison? So how far are we as a class from that bison? So we'll just call the hypotenuse x. And again, looking from the 72-degree angle, that means that we know the adjacent and the hypotenuse. So we could call that cosine of 72 degrees is equal to adjacent over hypotenuse. Again, if we multiply the x over to the other side, we get x, the cosine at 72 degrees, equals 300. And if we divide by 72, x is simply equal to 300 divided by the cosine at 72 degrees, which will approximately be equal to, if we toss that into a calculator, 970.820 feet. Now, it might seem like a large number, but again, think we're 300 feet high, and really, the hypotenuse, or the 90-degree angle, if this is only 18 and it's opposite of 300, our hypotenuse is going to be a fairly large line, so 970 doesn't seem out of the realm of possibility. Again, another option, if you want to check your answer, is you could have looked from the 18-degree angle. Only then you would know the opposite in looking for the hypotenuse, so we could have said the sine of 18 is equal to 300 over x. And if we do a little bit of solving, you'll also quickly find out that that's 970. Now, to switch our train of thought a little bit, if we want to find the second question, how far is the bison from the base of the cliff, we're looking for this bottom side here. And we'll just call that y. Again, we've already used x, so we may as well use y. You might ask why? Well, I'd tell you just because, again, we already used x. Sorry, bad joke right there. But 72 degrees is opposite the y with an adjacent of 300. So again, opposite and adjacent, tangent would be a great way to set that one up. The tangent of our 72-degree angle is equal to y over 300. Multiply by that denominator. Get that over onto the other side. Remember, we're dividing by 300, so we're just going to multiply it over. And then if we throw that into the calculator, again, 923.305 feet would be your solution to that part of the problem. And again, you could have also used the 18-degree angle. Again, it would have been a good tangent problem again. Use your good number, your nice solid 300 over here, opposite over adjacent. Then we would have ended up solving more similar to what we did in the blue. Again, still using a tangent, but we'd have our 300 over y, and you still should end up with that same side length. Hope that helps you understand how we can use trig functions to our advantage in fairly simple triangle problems, and I hope you have a spectacular day.